Unlocking innovation through robotics education. Welcome to our channel, J Robotics. Welcome to the world of electronics. In this video, we'll explore the components used in our flame detection project. We have an Arduino board, a flame sensor, a breadboard, a buzzer, a red LED, a green LED, and jumper wires. Each component plays a crucial role in creating a robust flame detection system. Let's dive into the details of our setup. In the second video, we'll guide you through the step-by-step process of connecting the components for our flame detection. Starting with the LEDs, connect the red LED's positive side to pin 3 and the green LED's positive side to pin 4. Ground the negative side of both LEDs. Moving on to the flame sensor, ensure that its ground is connected to the Arduino's ground, VCC to 5V, and the digital output, DO, to pin 2. This configuration allows the Arduino to detect the presence of flames. Next, for the buzzer, connect the positive terminal to pin 5 and the negative terminal to the ground. This setup enables the buzzer to sound an alert when a flame is detected. Double-check your connections and make sure your Arduino is powered, either through USB or an external power source. Before we upload the code, ensure you've selected the correct board and port. Go to Tools in the Arduino IDE, choose your board, for example, Arduino Uno, and select the port your Arduino is connected to. Now, you can upload the provided code. As we power up the Arduino, you'll notice the red LED and green LED on standby. These LEDs serve as indicators for the system's status. Now, as we introduce a flame to the flame sensor, watch how the system reacts. The flame is detected, triggering the red LED to illuminate, the buzzer to sound, and a corresponding message, "Flame detected," is displayed on the serial monitor. On the absence of a flame, the green LED starts to blink, indicating that the system is in the standby mode, ready to detect any potential flames.